Is Seiichi Yamada here? Ah. And Philippe Metzger? Not yet. Okay. Hello, good afternoon. We are waiting 5 minutes more to let presenters to come. Thank you. By the way, Seiichi Yamada, is he here? Not yet. Philippe Metzger. Okay. Waiting. Hello, good afternoon, everyone. Welcome to this session about architectural concepts and issue. I'm Paolo Caratelli, member of Moon Village Association and program leader and head of research at Istituto Marangoni, Dubai, Emirates. My keynote is related to space architecture and design for extreme environments. First of all, we have to agree what is an extreme environment, because despite it seems a quite a common concept, there is not a general agreement about how to classify an extreme environment, because there are several parameters. The only one that in our case, and especially talking about space habitation, is related to human physiology. Then an environment is considered extreme if chance of human survival are very, very low or almost zero, without specific training or specific equipment. Meaning environments that are very highly acidic or highly alkaline, hypersaline with a salinity superior above 35 per thousand, under pressurized, and this is the case of vacuum in space, or over-pressurized, meaning at the bottom of the ocean, very hot or cold persistently, not occasionally, extremely dry, and with high radiation levels. Despite that, there are some biological life forms that in some of these environments, they adapt very well and are known as extremophilies. But in our case, we consider extreme environments that they have one or more of these characteristics, including also other special cases of human-induced extreme condition, like contamination by radiation, high level of pollution, and so on. So the extreme environments that we consider, and talking as an architect, where also my discipline is focused on, essentially are 5: hot, dry desert, underwater, high mountains, polar region, and space. This, for example, is an example of an installation, a building realized in Sharjah. And I would, without this tree, you would even think that is a Martian environment, because these are the conditions: extremely dry, extremely hot. Or I think that you are acquainted about NEMO, so the installation realized to train as a space analog crews from NASA and ESA. Or even this one, Refuge du Gautier on Mont Blanc, that is one of the few completely self-sufficient buildings realized, having in mind a lowest as possible impact on the environment. Or even installation in Antarctica. This is the Halley 6th Research Station, designed by Hugh Broughton Architects in 2013. And since the project, this particular research station has been conceived having in mind an installation, a human habitation, like on another planet. You know that Antarctica is one of the most extreme places on Earth that is used currently as, again, as a space analog by NASA and ESA. ESA at Concordia station, that is Italian and French. So, what about space architecture? Space architecture is quite young as a specialization, as a discipline, has been codified not before 2002, during the World Space Congress in Houston, once a group, Team 11, Millennium Charter, they grouped in a workshop and elaborated this short but very efficient definition of space architecture. So we can think that the space architecture has a discipline born in 2002. But space architecture and the architecture system has been used in aerospace since quite long, and we will see. Compared, not opposed, but integrating the system engineering with a different approach that in architecture is used in design. We are perfectly acquainted that in system engineering we have function, then subdivide in subsystem, then tested, integrated, and then final product. So the final product in system engineering is, not researched from the very beginning, but is the best solution as possible, because all the focus is on functionality, not on aesthetics. In architecture, we start actually from the general idea or the concept, and with iteration, different sweeps of analysis, synthesis, and evaluation, we try to get closer and closer until we reached what is conceived from the very beginning, not as any solution, but the possible solution. So in architectural design is the concept that is driving, not the subdivision of the systems. And this has been called system architecting. System architecting that is considering different iterations, several iterations, not in a linear, but in a cyclical process. And again, talking about space architecture, we think that the contribution of architects is quite recent. Actually not. Since Apollo and Skylab mission, the contribution of architects has been practically the driving force for all the habitability studies. The designer Raymond Levy, that is well-known French-American designer, was the head of the design team that supervised both Apollo program, but most importantly, the Skylab. With his contribution, the general arrangement of the Skylab was obtained. The initial plan of the engineers, they were to use the third stage of the Saturn V horizontally. But Raymond Levy and his group immediately, they think in vertical, as a building, dividing the different function by floors. And by his contribution, we had also the story. I don't know how many of you know about all the drama around this, the very first window on space, because was practically one of the causes of Raymond Levy almost to break its contract with NASA, because the group of engineers, the engineering team, was refusing at all to make any opening on the structure of the envelope, because would have make the overall structure weak. So after several back and forth, practically the CEO, the administrator of NASA, allowed to create the window, because the intention and the idea of Raymond Levy was to have the window as the preferred spot for astronauts when they were eating here. And also the table was in the initial project, there was no table at all, of course, with microgravity. But as a designer, he insisted to have a sort of a table with a footrest in order to have the crew group gather together during meal in a sort of a configuration that is without any hierarchy. So not commander and the crew, but in an equal position, and have this moment, the highest and the most important moment of the entire day, because it's when the crew communicate each other. So this practically born as a requirement, psychological requirement, more than functional. And not only Raymond Loewy and Dalton, Maynard Dalton, they were working as an architect. Another architect in the Soviet space program, architect Galina Balashova, was in the same period collaborating with the internal accommodation of the first Mir station and also the initial internal design of Vostok and Soyuz capsule. Is seeing these drawings that are quite, moving, because of course there were not previous references how to arrange, how to accommodate the internal space. So the very first and the only reference that Galina had, it was practically a boat, a ship, or a railway car. So having this curtain and some elements in wood, so absolutely, or please note the fabric, the decoration of these elements. Of course, we are in a period of exploration, experimentation, no references, previous references. Despite that, she designed and she selected the color palette, having in mind that despite the microgravity, is needed a clear reference, clear orientation, down, bottom, and up. So, habitat design has a lot of implications that are quite common with the same psychological, physiological implication that we have also in terrestrial buildings. But there is an additional component, a very hard component, that is the isolation and the perception that beyond the thin structure outside there is the vacuum, and meaning death. So psychologically speaking, everything is introverted. Once instead in architectural design we make grant of the relationship with outside. In this case, all the efforts are to transform an interior in a cocoon. Sorry. I have to run because my 15 minutes are past, sorry. And these are the psychological issues that necessarily they have to drive the habitat design, where some situation and some psychological hurdles that and issues they could be over amplified, and then putting the overall, the entire mission at risk. So coming from the science fiction idea, the envisioned future, and I'm sure that you all recognized 2001: A Space Odyssey, this is the reality. So there is a big gap between what is envisioned and what is needed in real. And we are noticing also a paradigm shift in design. So this is the cockpit of Apollo capsule. And of course, the paradigm was the cockpit of a fighter jet. Same designers, same engineers, same industries producing the same vehicles. Today, this is a Dragon, and of course, the paradigm is the Tesla. It's a car. So we are shifting from something that before was designed to be extremely efficient, now efficient but also pleasant and easy to use. So even if we go through the interaction, I mean, man, human machine, from the Apollo to the shuttle till the Dragon, of course, even the psychological portrait of the astronaut is changing from the pilot, military pilot, trained for a dangerous situation, and to a traveler, the traveler of the future. And just to mention how much important is design, the importance of design, functionality. This is a news about a leak of oxygen from the ISS caused by what? By this hose that, if you notice, it looks not a very critical part, functional part. It looks like a handle. And since it was placed close to this window, all the astronauts, they used practically to stay in position until it broke and created a oxygen leak, and was forced to be practically sheltered, closed with a box to avoid that any other damage would occur. So this, the importance of functionality, or the importance how to design spaces for resting and sleeping. Again, till we are seeing short period or even long period, medium period mission. But once we are going to plan, for example, for a deep travel, deep space travel, going towards Mars, of course, are aspects of internal functionality that they have to be took in consideration, like personal care. This is the most expensive toilet existing in the world. It's more than $20 million as a piece of, as a machinery. So we accumulated enough experience in terms of habitability for orbital station. But in terms of lunar, we don't have, or at least we have a very, very few precedents. And the only vernacular precedents that we have, just to use a term that architects, they love so much, the only vernacular and the first lunar outpost is the lunar excursion module, only. Then we have to build all the following experience, starting from, temporary or permanent moon bases, like this one, designed by Foster, without forgetting also another aspect of design, fashion. Now we know that Axiom has designed the next generation of extravehicular activity suites with Prada. But even for the most famous one, this one was designed and produced by ILC Dover. ILC Dover, ILC is an international latex company, was a company well known for girders, bras, and corsets. So when they proposed a suit that would guarantee maximum vestibility, NASA was shaking because the first reaction was how is it possible that industry that is producing bras for a woman would produce a spacesuit, one of the best spacesuit that they have been designed. And this is the latest one, recently announced, financed by CNES, produced, designed by Spartan Space in collaboration with Decathlon. You know Decathlon, that is sport equipment, is an intravehicular activity suite that is currently under development. So just to conclude, and sorry for the length, especially for the next presenters, to conclude where to study space architecture in USA, there are not so much programs and courses currently where it's possible to get acquainted with space architecture or architecture for extreme environments. And the situation is not even better in Europe, that are only, excluding the very famous one, the International Space University in Strasbourg, there are only a few that they have programs at postgraduate level only that are introducing and teaching space architecture. To conclude, I would like to end with the words of Konstantin Tsiolkovsky. Earth is the cradle of humanity, but one cannot remain in the cradle forever. Thank you very much for your attention. And now I would like to call here Giacomo D'Amico for his project, his paper, so I can find, Selene, a self-sustaining lunar base proposal for 2070. Please, the stage is yours.
Okay, thank you. So, as humanity will return to the moon through the Artemis mission, establishing a permanent presence on its surface is becoming a tangible goal. However, challenges such as extreme radiation and the high cost of resource transport from Earth remain formidable. In response to the 2024 Space Design Station design workshop mission to design a fully operational lunar base by 2070, today I'm here on behalf of Team Vice to introduce you Selene Moon Station, our vision for a self-sustaining lunar base. Good afternoon, everyone. My name is Giacomo D'Amico. I'm an architect, a space architect, and a PhD student at the University Mediterranea of Reggio Calabria. I organized today's presentation in 4 sections to be able in providing an overview of our concept design. But first of all, I would like to acknowledge the other members of the team because each one played a unique role in achieving the concept design, and I want to publicly thank them to have achieved together the winning of this year's competition. And so let me introduce you the mission statement and motivation of Selene. We are considering ourselves in 2035. The mission was to reach and conceptualize an infrastructure network to be fully operational by 2017. The proposed concept shall enable a crewed lunar base and use in situ resource for essential subsystem and for establish a new lunar economy. The motivation of Selene are multiple, such as scientific discoveries enable future space exploration for long-term permanence and establish a sustainable lunar base as testbed for Mars and beyond. The general concept of Selene is establish a fully functional base on the Moon, pursuing the aim of being as sustainable and profitable as possible, but especially safe for humans, in order to ensure them a new home. The Selene mission architecture involves many moving parts, such as rovers, launch vehicles, and orbital station. There are various companies who have made this service available already, and so we advertise to establish partnership with them, to involve also the industry and contain the competition. For example, we would like to use Blue Origin's New Glenn and Blue Moon Mark II for transportation service, as well as the Crew Dragon and Starship by SpaceX, but also the Blue Seat developed by MIT, or the Gateway Station and other Artemis facilities and components. And about the business plan, because we were asked to develop one, we divided it in three main sections: the IS3 products, the Selene living and working space to be used as research facilities, also to be rented, and outcome and product for the public, such as wine, just to make profit. But so what is our timeline to address all these matters? Again, as today we are in 2035, we're going to start phase one. In this phase, there is a whole preparation of the first step to establish a permanent human presence on the Moon with a crew of 4 to 8 astronauts. Indeed, by 2040, we will launch the first cargo with inflatable habitats units, followed by the first crew launch 1 year later. Then, in phase 2, Selene station will be able to host up to 25 astronauts. A farming and foresting process will be initiated, and the ISRU will be enlarged. From 2055, as in our business plan, we'll start renting space and equipment. Finally, in phase 3, the station will be capable of hosting at least 75 astronauts and being full operational. The farm and the forest will be completed, but with the aim of expanding them in relationship to the need of the mission. The mission operation related to the cargo transportation will have an initial cargo from Earth to low lunar orbit via a weak stability boundary transfer. Then a steady state large cargo, Blue Moon or Starship will be used, and a steady state small cargo and supplies for the habitat. About the crew, we planned this kind of exchange of crew members over time, so I hope that the slide speaks itself. But what about the location where we are going to establish Selene? Sorry, I messed up. To set our lunar base, we took into account the available information regarding in situ resources available on the Moon, as well as the most advantageous location selected by space agencies. On this line, we picked the Moon South Pole. But why? In this region, on the Moon, there are the as known permanently shadowed regions that are promising source of water ice. At the same time, there are parts of it permanent daylight. For Selene, we selected the Gerlach crater near the Shackleton crater. On the rim of this crater, there is the advantage to use maximum sunlight for human factor and power generation. In the lower part of the crater, instead, there are the resources needed to produce fuel and get water via the IS3 site. Moreover, 2 launch pads are planned, one closer to the settlement for small cargo and crew, and one close to ESRU to minimize transport away from the site for the cargo. We also considered a 5 kilometer skip out zone from both settlement location and ISRU site to define the permitted azimuth for launches, the safe zones, and the no-flying zones, making a simulation of the possible launches trajectories. With the 5 kilometer skip out zone, we should be able to keep the majority of fragments away from the important sites. And going into the last part of the presentation, I'd like to introduce you the architectural concept design of Selene Moon Station. It is a multi-level and polyfunctional crewed base designed to be both modular and scalable over time, according to the needs. Selene is arranged both above ground and underground, but let's break it down together. The above ground settlement presents three types of units: the vertical habitation unit, the horizontal multipurpose unit, and then airlocks and emerging shelter connected via tunnels. The first one is named SHM, so Selene Habitation Module. It has a total volume of 1400 cubic meter divided into 4 levels and could host up to 6 astronauts. As you can see, it's designed to be a deployable structure with a multi-layered inflatable walls. In the undeployed configuration, it can easily fit into the spaceship cargo. Moreover, for the energy supply, a 34 foldable solar panel of 1 meter by 1 meter are considered. The internal configuration is designed to have the storage area at the bottom, then communal areas on the first level, and private pods and relax areas on the second and third level. The second unit is named SRM, Selene Research Module. It is 2070 cubic meter module arranged on a single level to be a multi-purpose unit mainly for research. And on another end, we have the underground settlement. In the underground, we arranged it on 3 levels, combining both living quarters and shelter, and hosting the greenhouses and forest dome. Yes, you heard it right, a forest, and we'll see it in a few slides. The decision of going also underground with the settlement was taken because it guarantees a natural shelter from radiation and provides materials to be used for commercial purposes and for building the settlement itself. But we had a problem with this solution, and we had any natural light to support human factors. For this reason, with the approval of the radiation engineer present at the workshop, we designed a periscope system to provide natural light while shielding the radiation. Anyway, it is to limit the cost of building it, the periscopes are limited to the research unit of the system, providing an enjoyable working area for the astronauts. These units have the dimension of a 6 meter in diameter by 18 meter in depth. Arranged on 2 levels, it could host up to 8 astronauts per living unit and up to 20 astronauts per multi-purpose ones. Finally, in a nutshell, Team Vice pushed this boundary and proposed a dome with a real forest inside. It functions as an ecological life support system together with farms and greenhouses and provide a glimpse of home to the astronaut, supporting the psychological well-being. So this one was one of our key points in the whole design. Finally, in conclusion, this is the utilization architecture of ISRU, and I would like to conclude with reference, but most with acknowledging organizer and the sponsor of SSDW 2024. And moreover, I would like to thank the MVA, Alessandro Bartolini and Paolo Caratelli for having me here today. And last but not least, thank you all for the attention by Team Vice. Thank you.
Thank you, Giacomo. Very interesting indeed. Now I would like to invite here Seiichi Yamada, Tasei Corporation, for a presentation about off-grid living in space, adapting the Satoyama philosophy for extraterrestrial habitats. Please, the stage is yours.
Good afternoon, everyone. It's a pleasure to be here. First, allow me to give you an overview of our Taisei Corporation. I touched upon it in yesterday's panel discussion, so please forgive any overlap for those who were present. Our company was founded over 150 years ago and constructs innovative and sustainable buildings and structures. Our biggest motto, which is also serves as a company philosophy, is to create environments where people can thrive. In essence, while we are a company that creates the hardware of the environment, our ultimate goal and motto is to enhance the well-being of those who live and work in these spaces and to create environments that lead to happy lives. Our global reach includes the following major projects. Palm Island Project. We outperformed our competitors with cutting-edge construction technology, earning high praise from local media. Almas Tower is also a big urban skyscraper project in the Middle East. Bosphorus Strait Project. We realized the century-old dream of connecting two continents. We boldly adopted numerous groundbreaking new technologies for undersea construction in strong currents, completing this difficult project that was said to be impossible. We are proud to have completed this crucial project, a long-cherished desire of the Turkish government. So now let me explain the construction of a lunar base based on a Satoyama concept. Humanity is taking its first steps towards a new frontier, space. Space habitation is no longer a science fiction fantasy, but a tangible goal within our reach. I'm sure almost all of you have simple questions like, why the Satoyama philosophy? How will you incorporate it into a lunar base? And still questions arise. Why do we even want to build a base on the moon in the first place? Is it for scientific or engineering research, to mine and discover resources for utilization, and for building a lunar city instead of surviving on Earth? Well, whatever the reason, building a lunar base presents significant obstacles and challenges. These include the harsh environment, extremely limited resources, and the potential psychological stress of long-term stays. In Japan, the concept of Satoyama, managed woodlands, illustrates a history of actively engaging with and managing nature to maintain biodiversity and benefit from its resources. Satoyama serves as an ideal model of human-nature symbiosis. Within Satoyama, wisdom about cyclical resource utilization was nurtured, such as using fallen leaves and branches for fuel and fertilizer. This provides valuable insights for building a sustainable society in the resource-constrained environment of space. Space habitation is a monumental challenge for humanity. However, it also presents an opportunity to evaluate our relationship with nature. Coexistence with nature means living in harmony with our surroundings, not dominating them. It means respecting the power and importance of nature and maintaining a balance between human needs and the environment. Resource recycling is another key principle of Satoyama. We believe in using resources efficiently, minimizing waste, and finding new uses for all materials. Sustainable development is about meeting the needs of the present without compromising the ability of future generations to meet their own needs. Now let's move on to how we will embody the Satoyama philosophy in a lunar base. I'll explain this while introducing a hexagon structure. Hexagons are utilized in various everyday objects like wrenches, bolts, nuts, pencils, tiles, and soccer balls, and is observed in various natural phenomena like beehives and snowflakes. Honeycomb structures achieve high strength with minimal material, making them suitable for applications requiring both lightweight and robustness, such as aircraft wings and building materials. Hexagons also excel in efficiently utilizing limited space. Hexagons require a shorter perimeter to cover the same area, thus saving material. Excel in expandability, space efficiency, and design potential, with future possibilities for improved cost effectiveness through material reduction. In architectural perspective, buildings incorporating hexagonal motifs often convey a modern and stylish impression. Sorry. Green zones within the base will provide stress reduction, food production, and air purification for the residents. The Satoyama concept encompasses various aspects. It divides the landscape into zones. For example, the concept on the left side of this slide aims to apply this Satoyama approach to lunar living areas. This represents an initial vision, not a finalized construction blueprint. However, we believe this concept serves as a helpful illustration of how Satoyama principles could be applied to lunar living spaces, which is why we are presenting it here. The outer black area represents the vacuum of space, a dangerous external environment. Plant factories act as a buffer zone, connecting the outer environment with the habitable areas. Green residential areas are located further inside, where people reside and live peacefully. Actual agricultural areas are situated, and even deeper within the bottom of lunar vertical shaft represents another dangerous vacuum space. The plant factories and the agricultural areas are both intermediate layer connecting the wilderness and living zones. This area is positioned as a buffer zone, an intermediate layer that enriches the interaction with nature. Creating natural environments for psychological well-being. Our lunar habitats are designed to generate more energy than they consume. We are accomplished in zero-emission building facility that we actually use it as a research center where I work at every day, including physical and mental well-being technique we've developed. And vice versa, In the near future, the new developed technologies through lunar-based construction planning, the newly developed technology applications will be utilized back here on Earth. This facility goes beyond simple energy efficiency. It prides itself on securing groundbreaking technology that achieves a complete balance between energy creation and consumption within the building itself, helping us to improve resource management, waste reduction, and sustainable technologies. Satoyama in space. Satoyama is not just a philosophy for Earth, but a universal principle that can guide suitable expansion and harmony in space exploration. Future space development. Our lunar base is just the first step. We envision expanding into larger lunar settlements, exploring Mars, and preparing for deep space missions. So is Satoyama philosophy only implemented in Japan? The answer is no. Sorry, I didn't prepare pictures or any slides. In ancient Greece, Temenos referred to sacred groves or forests where human activity was restricted and nature was protected. Activities like logging and hunting were prohibited in these areas, fostering a coexistence between humans and nature, similar to the sacred forests surrounding Japanese shrines. Temenos reflect the reverence for nature and the philosophy of conservation. In England, from the medieval to early modern periods, commons were shared lands managed collectively by local communities. These commons served as grazing pastures and sources of firewood, ensuring the sustainable use of natural resources like Japan's Yoriai common land. The commons represented the system of community-based resource management, supporting a harmonious relationship between humans and nature. The Spanish dehesa refers to a type of agroforestry system where communities manage woodlands and pastures. These lands are collectively managed to provide essential resources like timber, firewood, and grazing land for livestock. Similar to Satoyama, the dehesa functions as a mechanism for maintaining a balanced relationship between humans and nature. The German Mark, I don't know, also refers to communally managed forests and pastures. Villagers collectively manage these lands, sharing resources like timber and grazing areas. Like the Satoyama system, the Mark contributed to sustainable resource use and the well-being of the local community. At present, notably in Nordic countries, the right to enjoy nature is legally protected, as exemplified by the Allemansratten, freedom to roam. These examples demonstrate that Europe has a long history of diverse systems and philosophies aimed at achieving harmony with nature. They share common elements with the Japanese concept of Satoyama, including reverence for nature, sustainable resource utilization, and community-based management. By combining the wisdom of Europe and Japan and forging a new connection with the natural world, we can create a sustainable society even in a challenging environment of space. Finally, what is Taisei's vision for the future? With our biggest motto, which also serves as a company philosophy, to create environments where people can thrive. Through the advancement of space development and space habitat construction technology, we would like to aim to realize a dream of creating a better environment for Earth's society with a strong emphasis on international collaboration to achieve this. Thank you for your listening.
Thank you very much, Mr. Seishi. Now I would like to call on stage here Philip Metzger by University of Central Florida. In his presentation is Economics of Lunar Propellant Mining for Sustainable Development. The stage is yours.
Thank you. So the reason first of all, I'll just say I'm the director of the Stephen Hawking Center. Stephen, when he was alive, flew in microgravity, and he said that he believed space is our future, and he wanted the public to become excited and interested in space, so he commissioned us to start this center. You haven't heard about it, and he's long passed away because it took us 10 years to get it through the state legislature, but we have finally stood it up. And so today I'm going to be talking about why it will be economically successful to do economic development on the moon. I got tired of people who are skeptical, always using the same dumb arguments. And so I said, well, let's just settle it. And so I did like about a year of study and wrote an exhaustive paper. Let's see. So I'm going to, very briefly, for the sake of time, I'm going to show you some equations. I'll talk about the nonlinear effects that make the cost of products on the moon drop faster than the cost of launching them from Earth. As the cost of launching goes down, the cost of producing in space goes down even faster. So I want to show you why. Optimization of reliability, experience curve, economies of scale, economies of scope, and then I'll show you the results. Okay, so this includes cost of the capital, cost of transportation, which is a lot different than on Earth. This is the big factor. Cost of operations in space, cost of financing. This is also very large. And this is normalized by the mass of propellant at the lunar surface per year. So this is the cost per product per year. And these are the normalized terms. And with some manipulation, you can get it into this form where if this term is less than 1, these are all non-dimensional numbers. If it's less than 1, then it's cheaper to launch it from the Earth. And the primary, most important factors are G, that's the gear ratio, which depends on the transportation system, and phi, which is the mass of product per mass of capital over its lifetime. Okay, so now we're used, one of the reasons people are skeptical is because they're used to the way that space agencies do space missions. When you send a spacecraft to Mars, you can't repair it. It's got to be extremely reliable, and we pay a very high reliability penalty. And it makes sense because space agencies affect national pride, and it sends geopolitical signals, and so we can't take risks. So while space agencies optimize for those benefits, commercial activity is going to optimize for profit, and that's going to change the reliability estimation. So reliability drives costs. There's the rule of nines. Every time you add an extra 9 on the decimal place, 99.9% reliability, every additional 9 results in a factor of 10 cost increase. And the saying that we used to have at NASA was the last 10% of reliability is 80% of the cost of the mission. The numbers vary a little bit with the telling, but that's roughly true. And there's empirical data for this. So empirical data from industry shows that the cost factor for reliability scales exponentially with the reliability that you're trying to achieve, how much reliability is above the baseline. So if you build a piece of hardware with baseline processes, baseline parts, and then just whatever you get, that's what it is, that's your baseline reliability. But if you want to achieve a higher reliability, you're going to pay exponential cost. And so if you're going to get up into the 90-something% range, it's going to cost you like 1,000 times more than a nominal system. And that's what drives space agency cost. But if you can repair the hardware, because you're on the moon instead of Mars, and you're having frequent flights, then it turns out there's an optimum reliability. If you make it too reliable, then the cost of building your capital dominates. But if you make the reliability too low, then the cost of transporting all the spares to the moon dominates. And so the optimum reliability is right there. Well, it turns out that that optimum is a function of transportation cost. So right now, at $10 million per kilogram to the moon, you want to have a reliability around 93%. But as the cost goes down to, let's say, $20,000 per kilogram, then you could be around 81%. And so the reliability of your hardware goes down, and that means you've got an exponentially lower cost of developing and building that capital. Okay, the second factor, oh, and by the way, you might think, well, 81% is still going to be hard to get for the moon. It's actually not. I've gone through all the calculations, the reliability calculations, and the key is you're not going to replace an entire rover. You're going to build the rover modularly, and you're going to learn which parts tend to break most often. You design it so that those parts can be changed. And so you're only going to change the minimum mass that you have to. And by doing that, you can have a system that's only 25% reliable over a 10-year operational life. And by modularizing it, you can very easily get it up into the 80% range, where it's talking about the percent of capital per operational period that has to be replaced. Okay, the second factor is the experience curve. This is deep data on this. This whole analysis was based on real empirical data. And so there's centuries of industrial data going back to the Industrial Revolution. We know that production costs drop as we gain experience because we learn how to do management, capital, fabrication, labor, supply chain. They all improve as we continue to operate. And this has been fitted to empirical equations. This parameter B is the main parameter. B is typically in this range of numbers. It depends on the type of industry. So I exhaustively studied the literature for analogs to what we'll be doing in space. And I used B values that are in the appropriate range. And then I varied them over that range, as I'll show you in a minute, to make sure that these results are robust. The next factor is economies of scale. Production cost is less for larger operations. Now, this is distinct from the experience curve. You can have a small operation with a lot of experience, or you can have a larger operation with not much experience, or you can have both, or you can have neither. So this is a distinct effect, and the literature discusses that. But we know that production costs are less for larger operations. And we have empirical data. The main parameter here is A. There's a lot more variety in this, but it typically goes from 0.2 to 0.85, depending on the type of industry. And again, I searched the literature for analogs to the type of work we will be doing on the moon. And I'm going to use A values that are appropriate, and I'm going to vary them over a large range. Finally, there's economies of scope, additional business activities. So, for example, a farm that sells one product may decide in the off-season they can grow another crop, and so for the same capital, they can make more revenue for only a marginal cost of operations. And so by having economies of scope, these overlap of asset, skills, and processes, you get additional gains in the experience curve, additional gains in the scaling efficiencies, and you can get vertical integration. So for example, if you're going to be mining lunar water, you could also use the same rovers and some of the same processes to make metals or to do construction of landing pads for other customers. And I took that into account, although this was not as great a factor as I thought it would be. So I put this all together in a fully integrated model. I even modeled how the launch costs would drop over time using really realistic, empirically based equations. You can read the paper. It was published last year. If you want to find the paper, search my name, Metzger, put cost of lunar propellant, and you should find it. So here's the results. I have to explain this plot a little bit. So this is the cost. It's going to tell us the cost of propellant at different places in cislunar space. 0 is low Earth orbit, and 6,200 meters per second, delta V, is the surface of the moon. And so this is low lunar orbit. There's Earth-Moon Lagrange point 1, geostationary orbit, distant retrograde orbit around the moon, and geostationary transfer orbit. And then this is the year from the first year that you start to produce propellant on the moon. So the colors are the cost, and over time the cost drops. But the dark dashed line means on this side it's cheaper to get it from the moon. On this side, it's cheaper to launch it from the Earth. Now, this example, I ran many different cases for different technologies. This is an average of all the different mining concepts. I used all the different papers in the literature based on their estimate of capital, mass of capital, and all their different parameters. And so this is the average technology. And so this says, right from year one, lunar surface and low lunar orbit, it's cheaper to get it from the moon. But within just about 4 years of operation time, you can get it all the way below GEO or out to distant retrograde orbit, cheaper from the moon than from Earth. And then within about 7 years, it's cheaper to get it down to geostationary transfer orbit. So now you can begin boosting ComSats at a profit, cheaper than launching it from the Earth. And this is an average technology. There are technology concepts that are much more cheaper than this. Okay, now that was without solar electric propulsion, just to show you some examples of the different parameters in the model. You're using lunar propellant to deliver to the low Earth orbit, so it's going to take more than 30 years to get it cheaper down in low Earth orbit using this average technology. But with solar electric propulsion, it takes only about 19 or 18 years, and all the way down to low Earth orbit, it's cheaper to get it from the moon. I'll show you some other examples in a second here, which are even more optimistic. That just shows you there's a lot of parameters. Okay, so once you do this analysis, you can find out that the operational cost is a very small part of this. The cost of building the capital is a significant cost, but this is finance. Finance is the majority of the cost. And this is after year 30. Finance is still the majority of the cost. And this shows you that there could be a fantastic role for government and public-private partnerships. If you can bring this way down, then this industry could get started a lot sooner. I thought, well, what if I'm being too optimistic on the market size? Well, you can reduce the market to 1/10 or even to 1/100th, and it only has a slight change in these curves. You can see that getting it affordable down to low Earth orbit only takes a couple years longer with 1% of the market size. So it's not too strongly dependent on the market size. That's because launch costs and space operations costs both scale with market size. Okay, so I'm not going to explain this curve here. Look at the paper. I just want to show you that varying all these economic parameters, you get a bundle of curves that don't vary by too much, and in every case, it drops, which means that the product from the moon outcompetes launching it from the Earth more and more over time. Different technologies, the tent sublimation method is vastly better than the strip mining method if it works, which hasn't been proven yet. But strip mining can operate at much smaller scale, less capital investment. So I think start with strip mining and over a few years, switch to larger scale options may be the best way to go. Public-private partnership, the curves get better. Market sizes using public-private partnerships. Okay, one last thing I want to mention, the effect of innovation. These were using today's current concept of technology. Innovation is open-ended, and as you innovate, improving your baseline reliability in all different types of technology, you only improve. We've been innovating rockets for 100 years. We have not been innovating space mining yet. So this story's only going to get better as we go forward. I'll skip this for the sake of time. Okay, so this analysis, I sent it to many business leaders and economists before I sent it to a journal for publication. They had really helpful comments, but they did agree that the analysis was correct. Their main concerns were with the reliability of the operations and the ability to have adequate autonomy. I think autonomy is being solved. Reliability, I agree, that is the main issue. We have to design, we have to perfect the hardware, but having run the equations, I really believe that this is solvable by designing modular systems where robots can repair robots. And so a government-led effort to advance this technology could be revolutionary for the world. Thank you.
And now I have the pleasure to invite here on stage for the panel discussion, Woman to the Moon, moderated by Ernestina Binni, advisor of the director at ESRIC, and panelists Ms. Abigail Calzada Diaz, Abby Hatti, Carla Muttoni, Gabriela Nguyen Groza, and Rachel Klima. Ernestina, yeah, okay. So it's welcome. Missing the shade.
3, 4, 5. No, I think I will be here.
So there are enough chairs, or
I think we have enough.
perfect.
Is it working? You know.
Thank you.
Hello, everyone. I should admit that I'm very happy to be here, and thank you to stay after 1 hour, let's say. I suppose you are quite busy anyway. First of all, thank you to Mon Village Association and Abigail for the idea of the workshop. I really like the name Woman to the Moon. That means a lot of things, because I don't know if you are aware, but we had 12 astronauts on the moon and no one were women. So, you know, there are a lot of meaning behind these titles. Thank you, Abigail. Very good. And just I would like to introduce myself. I'm Ernestina. I'm working in ESRIC, but today I'm representing Women in Aerospace. The association started in the US in '85 because, let's say, the gap. Thank you. The gap in gender diversity was recognized. I'm sure that everyone knows very well that the space sector at the beginning was mainly men drive. And then in 2009, the European branch born in ESA. So we are part of the European Association with the headquarters in ESA. And we have a big representation on the women around Europe. So the panel, the topic of today will be to analyze the challenges and opportunity in space related to the gender diversity, but also in the multiculturality of diversity, age, and everything that can be, let's say, inclusivity. I will leave my panelists to introduce themselves. I'm sure they are better than me. Please.
Hi, everybody. Can you hear me? Yes. Thank you for being here. I think this panel is very important. So thank you for the association. We really appreciate this panel. So my name is Carla Mutoni. I'm tech entrepreneur, at least 20 years in IT industry. I'm economist, but also I'm engineer. And I have a specialization in space systems. Now in this moment, I have a company in United States and in Latin America. And 5 years ago, I started with this idea of create a new space startup. So that is why I have been working the last 5 years in robotics, between United States and now from Luxembourg.
Thank you.
Hi, my name's Abby Hutty. I work here in Luxembourg in iSpace. I'm the lead systems engineer for some of our rover platforms. And prior to that, I was in the UK working for Airbus Defence and Space in their Mars rover project. So I've got 15 years experience in planetary rover development.
Hi everyone, I'm Gabriela. I do not work in the space industry. I work with the space industry. So I'm the managing partner of AMROP Luxembourg. AMROP is a global network of 69 offices in the world. We are doing two main things: leadership development, and I'm working a lot on with boards and C-level people on that, but also executive search, so recruiting members of boards and also C-level people all over the globe.
Hello, I'm Rachel Klima. I saw some of you yesterday. So I have been in the field about 20 years if you count graduate school. My background is in studying remote sensing of planetary surfaces, including the moon and Mercury and Mars. I started out just really doing fundamental science and looking at the mineral composition of planets, but I have, over the course of the last 15 years, been fortunate enough to have the opportunity to build the Lunar Surface Innovation Consortium, and I served there as director. And now I have, I'm a group supervisor at APL, so I have about 30 staff members, which are actually more than 50% women, which is kind of rare in our field. So it's pretty great. So I also very much appreciate the opportunity to be here. Okay.
Hello. Well, some of you already know me from this morning. My name is Abigail Calzada Diaz. I work as a senior researcher in ESTRIC here in Luxembourg. Yeah, I want also to say thanks to the Moon Village Association for allowing us to have this panel today, because I think that this is a very important issue that we need to tackle, and I think we are waiting too long to actually tackle this thing. I think it's about time. No, don't you think? Okay.
Yeah, I would like to add, probably we know, but I don't know if the auditorium knows, there was a workshop and a lot of study done by UNOSA last year, and they released a paper, Space for Women. And it's clear that there is a gap, and between the action, let's say, to reduce the gap, there is create awareness about the situation. So this is the main reason why we are here, create awareness and see what can be done. Because Rachel said that in your institution you are 50% women, in your group, exactly. That's the same for ESRIC, and what I can say that is, you know, this is a policy behind that is bringing to reach this percentage, right? Okay. So let's start with our conversation. I'm sure that will be interesting, seeing the level of the panelists. And I would like just to start with the research side, with Rachel and Abigail. Can you, let's say, from your point of view, explain it to us what brought you to the space sector and which one are the challenges that you face as women in this sector?
Okay. Well, that's a good question. So I studied geology in undergraduate school and actually wanted to do something very practical. Because I needed to make money, actually, and get a job because I paid a lot of money to go to school. That's an unfortunate consequence of the United States system, and didn't think that I could go to graduate school right away. So I worked for a while, went back to graduate school, and was looking to major in hydrology because I knew the world needed water badly, and it seemed very like a good way to continue geology in a more practical way. And I was fortunate that the hydrology professor at the university that I went to also had a Mars grant. And I had always loved space as a kid and had the opportunity to get involved with mapping some of the patterned ground in Utopia Planitia for my master's. And then I moved to Brown University because I really wanted to know more about what the rocks were made of. So not just look at the pictures and the patterns in the ground, but to really find techniques to learn more about gamma ray spectroscopy, infrared spectroscopy, and things that can tell you about the actual composition of the rocks. So I guess I loved it as a child, didn't think it was something that I'd ever get to do, and then kind of fell back into it, fortunately. And I had a fantastic advisor in graduate school who was one of the few women actually advisors at that time, Dr. Carly Peters, and she was an amazing mentor for how to kind of navigate a field that was very dominated by not women.
Okay, my case is pretty similar. I mean, also I did my degree in geology as well, but I always have this kind of fixation with the skies and with astronomy. You know, when I was a child, I actually wanted to do a PhD in astronomy, even though I was not really sure what that means because I was very child. And it's like even when I was a child, I used to draw plans of making houses on the moon. So actually, it's like I like the moon because it was the only thing that I could see from my toy telescope. So it's like, okay, it's nice, it's beautiful, and actually when you look it through a telescope, the moon is incredibly beautiful. So I always like it. So surprisingly, in the life, sometimes I ask myself, it's like, how I end here? Because it's like, it was like such a crazy path until I'm here. And I'm happy to be here because what I like to work on lunar-related topics and there is so many topics to do about that. About the challenges that I face, it's like in general, I used to think that I didn't face many challenges. That is what I used to think. Until it was during a time that I did some self-reflection. And then I noticed that actually there were many challenges that I needed to be addressed. And in most of the cases, it's how women are educated. How women are educated to show themselves up, to be quiet, be nice, don't be bossy, and that kind of things. And that if you do a good job, everybody's going to recognize you. And changing that set mind, it was really difficult in that, because it's really something that we have interiorized so much. So I think that was the main challenge. Fortunately, I didn't have that main challenge more dangerous or more obvious that I know where, but always when you think about it, it's like, yeah, actually that could be some kind of reflection of a not very, a kind of discriminatory thing. But in general, it's most like interior thing. It's like how we are educated.
I forgot to say something about a challenge.
Yeah.
So one thing that I was really happy about with my advisor is every class in college, in university, was you get judged on how much you speak up, your participation in class. And I had one class start that Carly was leading, and she said, just because you speak louder or more doesn't mean you're participating better than everyone else. So she made it very clear that it was the content of what you brought to the table. And they taught me to speak up louder, but also didn't make me feel small that I wasn't brave enough to speak up. So I think that helped a lot.
Yeah, I should admit that we have already touched two important points that we discussed. One is the mentor. The other one is how we are educated. And now I would like to invite Abby or Carla to jump in. Abby, for example, you can explain your experience in a corporate world as your boss and then more startup style space. Would you?
Yeah, sure. So I studied mechanical engineering at university. There were 12 women in 212 in my undergraduate degree. So it was quite a big gender gap there. And I guess whilst I've had some very supportive mentors and guiders throughout my university career and then through my corporate career as well, I would say that there has always been an ever-present presence of detractors as well, people that will say that you're only there to fulfill a quota and that maybe you don't deserve to be there, even if you outperform them, even if you demonstrate your capability. And then there's all of the really low-level but pervasive just evidences that you are the first, or that people like you haven't been there for long. Like there are no female bathrooms in the factory facility. You have to go to another building. There aren't any personal protective garments available in your size. They can't even buy them because they're not made in your size.
Can I just, are you speaking about your experience?
Yes.
So 10 years ago? Oh, okay.
Yeah.
In UK.
Within the last 15 years.
Yeah, exactly. I just would like, to say that we are not speaking about the past generation. We are speaking about a young lady in Airbus UK. When you say big company and one of the most advanced nation on the world. So, just pointing out.
Maybe going to be a resident engineer at a subcontractor managing the manufacture of something that I've designed, and then they just do not have female facilities on site at all. Just things like that people think, oh, well, we don't have a problem. We've never had a problem with this. Well, that's because you've never had women, but actually it's a very big problem if you are a woman. So there's that attitude shift that I think that people aren't trying to exclude women, but they also haven't identified that there are a lot of very low-level but pervasive barriers to being a woman and operating in that environment.
Yeah, thank you.
Well,
in my case, and I'm going to talk about from the entrepreneurship perspective. I'm in the space sector because I think it was a kind of revolution. I never liked the status quo, and I grew up probably in a very unequal gender society. So that is why I start with economy first in my study, and then I decided to continue with engineering, where probably we were just 2 or 3% of the people inside of the room, we were women. And I started in the space sector because I never saw a woman in the space industry in Latin America, where I grew up. And the challenges that I had to face, I mean, I can give you a list of the challenges. First, to be a woman in this aerospace industry. Second, to be in a region where in that moment, space, it was science fiction. So it was a woman talking about space. It was a woman talking about space robotics and how we can explore space, how we can do something in the moon. It was a huge challenge in my society for the mindset of the people. Not just because it was a woman, but also because someone was talking about science fiction. So in this context, obviously, I faced many comments. I faced not having support from government or from private. So I had to decide first to build a second company, which now is very successful, and because I didn't get the financial support. And so I had to create this second company. And thanks to that second company, I could invest myself in my second project. And second, I had to leave my country because I was talking silly things. So I moved to United States. And in United States, I felt that I was in my place. Thanks universe, NASA opened the doors for me, and I started to accelerate my robotic project in NASA Ames. And then many things changed, but I have a very long list of challenges that I had to face.
Yeah, I think that we had already a very good observation. I've prepared before the question for Gabriella, but now I will say, Gabriella, you are not in space sector, but you are building, let's say, a leadership program for women only because you have listened this lady. What are you thinking? Because this is what I want to ask you. What do you think?
I think that we have space for improvement. So as I told you, I'm not in the sector, but I'm working with the sector, recruiting high-level people and also working on leadership development. And yeah, there are a lot of things to tackle, I would say, and you were able to hear these challenges that they are facing. Hopefully it will improve tomorrow. I think that, I would say that we cannot exclude half of humanity from progress, and this will not happen. And we see these ladies who are really high achievers. I think that there are two ways about female leadership. I mean, female leadership is a two-way street. One of my clients told me once. Of course, the companies and society have to do half of the way. And Airbus, I hope that they created the women facilities, and also I think you were talking about shoes in smaller sizes for female engineers. But also I think that it's about women to take the lead and to take their part of responsibility and go for it, and you show it very well, that you are doing that. I am Romanian, and I was lucky to be born in a society where we didn't really have this kind of gender gaps just because we were communists. So I think that this is the only positive in heritage that communist, left in Romania, and everybody was equal. There was not a gender gap, neither in the mindset nor in the, for example, the pay gap. There was not a gap. So I always say that I was lucky to be born in that society at that moment in time, because I always say I don't have the shitty committee in my head, and the shitty committee is that voice inside your head that says, I'm not good enough, I don't belong. And I think that, as you said, Abigail, this voice is coming from the way we raise our children. I am lucky to have one daughter and one boy. And I think that we need to be very careful on how to raise our children, boys or girls, because usually we raise boys to be competitive, to be risk takers, to go for it. And we raise girls to be nice and shut up. And this is what we are doing when we grow up. So I think that as women, first of all, we need to take our responsibility and to go for it. And to face the challenges that we have, because we have a lot of challenges. And also as parents, we need to take this topic in our hands and be very careful about how we raise our daughters, but also how we raise our boys.
Yeah, thank you. Correct. We should take in consideration the complexity of the population. We will speak about that maybe later on. I just would like to underline what you said, right? When we are speaking about gender diversity in the UNOSA report, they are saying that there are three main points. One is the individual, as you say, is the woman themselves that they let's say not there, right, to be in the leadership position, or they are thinking that they are not good enough for science, something similar. So the individual. After we have the organization, so here we have the policy, as for example, to have the good environment, the quota that can be good or bad. There are a lot of reflection on that. Sometimes they are good, sometimes, they can be seen as not an advantage for ladies. And then there are the structural of the organization in sense of biotics, stereotypes, and so on. I think that we are going on the point. Now I would like to ask you, and freely answer one after the other, what we can do, which one are, let's say, the practical things that we can do to move forward and increase the gender equality somehow in terms of everything, cultural also, and age.
So I think that there is two main points. It's like what we can do as individuals and we can do as a society. So as individuals, all the women should do this self-reflection, and also the men should do this self-reflection. Is like who I am, what I want, and how can I achieve it there, despite I'm women, men, or whatever. So that is one thing. It's like the individual. Also, things at an organizational level, like in industries, like keeping, as Abby say, keeping on point. It's like, okay, we also have women joining the industry settings. Maybe we should think about them also joining the settings. And that also is allowed. I mean, it seems that it's very little, but actually it's allowed. And then as a society, I mean, a big problem that I think women and many other people face, but especially women, it comes from the upper part. It's actually it's a problem more political. It's like we need to force that the legislation and the policies take into account that more women get into this in any sector. If we go into the labor, that that is something that we need to force, but together as a society. And then it's like also as a personal thing, it's like, I think that I don't know for all of you as well, and I would like to know, it's like, for me, a big part is like, we talk about conciliation, and it seems that conciliation is a thing that women and companies have to do. But actually, conciliation is for all of us, men, women, everything. We have to think about more like our life, like this kind of combination of work, home, chores, time for enjoying, for sleep. So all these kind of things also we should think about, as men or women. Yeah.
I really like the point of self-reflection that indeed I think all the ladies that are on stage at that moment did once in life.
Well, yeah, I totally agree with you, Abigail. I think education for me is the basic of everything. And if we want to change, we need to do something with how we are educating our girls and also our boys. I think also it's important the role models that our society are putting in the mindset of everybody. To include more women in leadership positions, I think is fundamental, because it's very important for every girl, every woman to feel inspired and to feel that they can do big things. So to have role models, I think are one of the most important things for me.
Sorry, can I jump in? Role models, because I think when you come into a room and you're the only person that looks like you, whether it's a woman, whether you're a minority in your country, even if you don't recognize that you're feeling it, you ask yourself, am I supposed to be here? Do I belong here? So I think that as a leader with things like this, with panels, trying to be very careful in selecting the panels so that you have, and not in a tokenizing way, but to go, one thing we did with, when we were planning panels for LSIC is we would call companies and say, okay, I know you want to send your business development person, but I saw this other person on your staff who has the expertise we need. Do you think she might be open to coming? Just so there's someone there. And then it kind of grows from there. So I think that's very helpful. I think also to make a space where you feel that you are there because you are desired is a weird word, but like you are valued for your contribution, and not that you are just being told you can come into this room that's our room, but you're okay being here, is a very different feeling from being invited for your expertise and for your what you can contribute. And I think that the more you can make sure that that's how people are being treated, the better it is for everyone. Because I think there's all kinds of studies that show that in an environment like this where you need to innovate, if everyone is the same, no one challenges anything, and you fail. So you need people that can question things and think about things differently. If you want to succeed at something that's so fundamental as learning how to live on another world. So,
for me, I would say a lot of it's allyship and also leadership. So we need to recognize that at the moment, women aren't generally the people in positions of power and the people that can actually enforce institutional change or societal change. So we need allies in those positions of power. Where we have women in leadership positions, we need them to be helping the generation that follows and to be actually addressing the things that need to change, the systemic difficulties that exist. Rather than, I think, sometimes we even have women who get to positions of power and then almost try to maintain the status quo because somehow they've achieved in getting there, and therefore they think that everyone else should be able to battle through the same challenges that they did, rather than dismantling those barriers. So in terms of allyship, I think we need people that are going to actually consider whether they have unconscious biases and whether they can actually change their attitudes, their mindsets in terms of what they need within their business, what a leader looks like even. Women don't often lead in the same ways as the alpha male kind of model of leadership, but that doesn't mean that they're not leading, and that doesn't mean that they're not successful in the way their teams are organized and run. But if you picture a leader and you picture this alpha male, then you're never going to promote a woman into that position. So there's a lot of addressing our own internal assumptions and addressing our own internal biases and actually questioning, could we do this differently? Could we make space for it to be done differently? Could we reward people that do it differently? And try and tackle that. And that makes space not just for women, but for other people that have other ways of doing things, and that can make an environment that's better for everyone.
Yes, just one observation before to pass to Gabriella. You touched two important points, one from Rachel, one from Abby. The one from Rachel is the importance of diversity for the innovation, and the leadership model that we have. Maybe we can speak later on more deep on that. And I think that in the report from UNOSA, they are saying that 11% of leaders in the space public sector is women, so in the private should be less. And I should admit that when I read that 11%, I said it seems to be too much based on my experience. So I came through the data, and I find that 11% is considered HR. Big percentage, right? Exactly. And so when after we are speaking about engineering and leadership position in a technical domain, that's different. That's different. And also there was the analysis from country. And Luxembourg, it's not, it's lower than average over the world. Now I don't want to give numbers, but was not. I was reading the numbers, said okay. I was thinking that Luxembourg was better than that somehow, but that's as it is. Nothing to say. So there are ways to improve, right? Gabriella or Carla, do you want to add something? About
I already
okay, no, because you were
but no, just I want to say that the 11% sounds very high.
Yes, exactly.
And I know I have been doing research in the ecosystem here in Luxembourg in the space sector, and there is just 2 women that are founders in the space sector here, and there is 80 private startups. So that is nothing. And just 0.6% of private equity from venture capitals are going to women here in Luxembourg.
Yeah, from my perspective, I work with a lot of sectors, not only space, and I see how it went in the other sectors because, frankly, professional world is a world that was created by men for men, and we women, we are kind of intruders. We started working massively after the World War II, and we have not really achieved gender equality. So I think that is important for the system to open up. Is important for us to find allies in men. It's not about women versus men. It's really also finding allies in men leaders, and it's actually very pragmatic. You cannot have half of humanity not to contribute, to your sector, or half of your workforce not contributing to the company. And it's not about women becoming men by their behaviors. It's not about transforming women into men at leadership positions, but really making them get there in that leadership positions and then opening up the door for other ladies. And I think that we as women also have a responsibility in terms of role modeling, because women in high level positions, sometimes despite themselves, are role models for other people, men or women. So we need to be aware that all the behaviors that we show in this leadership positions are looked up to and sometimes challenged by more junior people. So we do have this responsibility of getting there and opening the door to other people, and also in not transforming men into enemies, but really in allies, because all the men have daughters, wives, or sisters. And basically, we all need to contribute as human beings to the society.
Yeah, thank you. I was speaking yesterday or last week, let's say, with different men, that would you like to be part of our association because believe that gender diversity is important in space and we can provide a different perspective. And there was a guy that is a leader in the space sector of Luxembourg, where I was speaking with him about the leadership model of men, and he made a reflection to me, and he said, you know, this is a model that we call men, but a lot of men doesn't recognize themselves in this model. We should, and that's true, right? Why this model of, you know, to be someone that is very assertive, someone that is, you know, always strong, always this Superman, but maybe, you know, also men would like to have others leadership model because maybe they are more negotiator, they are more calm, and they would like to discuss, to speak together, and so on. So yeah, in reality we have a model. Probably that is okay also for some ladies, from women, but maybe is, you know, we should open to different perspective in this case, right? So to admit that there are different type of leadership that can be used and so on. Yeah, we have a few minutes left. If you want to add something, please feel free. I have one point that we didn't touch, and that is the importance of the policy in the work environment, but you can, as it's last minutes that we have, feel free to add quotes or say what would you like to say to end the discussion.
Well, for me, one of the biggest challenge, it was the financial challenge. And I had to do a second company in order to have the financial support. And when you mentioned these numbers, I think they are not very good. If we consider that just 1.8% of the venture capitals and angels are investing in a startup created by women, I think we are not doing a very good job in this society. Just 1.8%. So we need to do something. We cannot expect that every woman who wants to do something in a space create a second company in order to invest in their own companies. I mean, it's too much work. So we need to do something from that perspective. Thanks.
I would maybe say on the policy side, a lot of companies will have policies and will think, these are our policies are fine, we've never had a problem with them, but then they don't have people of certain groups from within society, whether that's women, whether it's people from lower socioeconomic groups or people with disabilities, other minorities. It's like saying, our lift's broken, but we don't have any disabled people in our office, so that's not a problem. Well, you can never have any people that are disabled in your office if you don't fix the lift. And it's exactly the same with other policies. So we need to preemptively fix the policies to make sure that it's an even playing field for everyone that might want to join the industry, rather than waiting to find out that there's a problem later. Because maybe the reason that you don't have the people is because they're already excluded by your policies. Correct. So it's very difficult to see those things. It's very, you're blind to them because you don't experience them as problems. And that's not necessarily because you have any malice or poor intention, but you almost need a worked example of somebody coming along and trying to go through the system to identify where the problems are. And it's very easy to dismiss those problems as trivial until you've lived that experience. So, yeah, we need to address this in a different way, and it's very difficult to do, but that's a good place to start.
Thank you.
Yeah, it's like I have limited faith in policies within the company if you don't have anything to actually supervise that policies are actually implemented. Because there are many, many companies, and probably we have many of mine, that, yeah, they have inclusivity programs, they have, but it's like, okay, nobody is to supervise these programs that is happening. So I think we need an extra level to actually be sure that those implementations that have to be in all the companies and institutions are actually implemented. And there are people to say, hey, here you are not doing it right. You have to go and do these things and provide guidance also into how to apply these policies within the company, within the institutions, the school, and everywhere in the society. So again, I also think that the government has a lot of things to do, that we cannot do everything by ourselves, but we need to push. Definitely what we can do is pushing to the companies, to the policy makers, to everybody to go and implement these things. Not just put it in paper. That paper flies away. So actually it's like, no, this is in paper and we are going to do it now. That is the thing.
I don't know if I have anything to say about policy. I think the biggest issue that we've run into with policies, especially like kind of trying to look at the gender diversity and minority diversity in our company, is that they kind of lay out what they want to do, and then they get a little improvement, and then there's a lot of like jubilation and, oh, we're so amazing, and now we're done. Okay, let's move on. But maybe the chart will say, okay, so now we have 20% women across the lab, but actually for the last 15 years we've had 4% African Americans, and they, just kind of slip that under the rug and don't talk about it. Or, and rather than coming in and saying, hey, we're doing a good job, we've got more women, it's still not 50-50, but, there could be all kinds of reasons for that, but how do we make it better? What's the environment like for the people that are here? And where are we falling short? So instead of just congratulating yourself when you've made a little bit of progress, to keep looking at the barriers for everyone that they're experiencing and re-examining what might be holding people back.
From my perspective, I think that policy is a very tricky question because people can be hurt by some policies, and I see it in my everyday work. I'm working a lot recruiting independent directors for boards. So in the last years, we had a lot of demand from women independent directors, and now we have a kind of a pushback from men saying, but it's only for women. If I am a candidate for a position, I know that they will give it to a woman. And this is not true, actually, because I never saw a client, selecting an incompetent woman over a competent man. And this is what I'm telling to women and men. So, I think that policies can be tricky. But from my perspective, of course, this is not a perfect, companies are not perfect, policies are not perfect, the system is not perfect. But what I would do is really be smarter than the system. And my advice to all women is really play by the rules of the game, get there. And once you are there, you open the doors for other women. And you make men not enemies, but allies. Because if you explain to them that you are an engineer, you went to to a company and they were not able to give you shoes in size 36, they would understand that. If you explain that there were no women facilities, they could understand that. So it's really about allyship and role modeling and being smarter than the system as it is today. And this is how we will change the system, because if we go and confrontational, it will not work.
I would like to conclude saying that anyway, I'm very positive on the subject, because we are speaking with the new generation, right? A lot of you are mothers already, and we know that, let's say, there is a certain, they are thinking in a different way, right? And this is also thanks to education. I always say that, I am sorry to say, but indeed, I'm from Italy, and when I was in the primary school, I remember a lot of discussion about minority and the fact that we are all the same. But it was really discussion on difference in a cultural way, and I never heard, if I remember well, someone at school said to me, no, you have the same right, you are the same, you can do the same things. And so this is the message that we would like to bring now to the new generation, and I think that we are really in a good way. And thank you so much.
Thank you.
think that I will stay. It's okay for the second part. It's. Thank you. No, thank you. Yeah. Can you change the presentation over there? Yes, thank you. Thank you. Thank you. We have still 10 minutes for, and then after we will be in the break. Please stay here 10 minutes because it's a very important topic. This time I'm not anymore a woman in aerospace, but I will dress the clothes of Esric. Can you check? They are changing. Yes, they are changing. So I will introduce the topic. It was introduced yesterday in reality during a panel on lunar economy. As you know, in Esric, we are having a pillar in commercialization. The presentation was not this one, but doesn't matter. That's I can, okay. Yeah. We sent the presentation today, but doesn't is we have sent the presentation this morning. Okay. Well. I think that will not done. Doesn't matter. Some of you knows already, so we are running the Startup Support Program. The Startup Support Program is in cooperation with ISA. We are launching 2 calls per year, and we are on the 50 call. And today we will announce the winner for the call number 4. It was quite challenging. And this time we will announce two winners. One is in the room with us and is from Peru, Tumi Robotics. And the other one is Neamin from France. We don't have the presentation. Ah, okay. Okay, it's just... Yes, okay. Just to reintroduce Esric, we are, as you know, we are in Luxembourg, an initiative of Luxembourg Space Agency in cooperation with Luxembourg Institute for Science and Technology in partnership with ISA. We are involved in research and innovation, everything related to space resources. And concerning the commercialization, we are having the Startup Support Program, the Acceleration Project, and the Challenge. Yeah, can you give me that in the meantime? It's what's happening, normal. Here we are. Not very good. Doesn't matter. So, we have already 3 companies incubated in Luxembourg. One is 4Point, the second one in Litigo. Litigo was in the panel yesterday for prospecting. And then we have Space Backend that was today in the panel with us for lunar resources. And then we are running the SSP4 and the SSP5. Today we will announce the SSP4. As I said before, we have 2 winners. And the first one, you can go to the second slide, please, is Tumi Robotic. Yeah, Tumi Robotic is a company from Chile. They are in the space mining sector, and they would like to go in space. This is a classical example of what we do in Luxembourg in reality. It's quite interesting how a company from Peru will come in Europe and then will choose Luxembourg to be with us. And the second one is Neamin. You can go to the third slide. Can you go? Thank you. Very bad. Yes. Neamine, this is a company from France. We know the co-founder very well because has already collaborated with Esric for different activity. And there is, let's say, something that unified the two companies, and this is what we underline to the startup when they are going to start their ventures, is that you should have an activity on the terrestrial application. This one will support the development for space. So both of them, let's say, will have this point in common. Okay, so I think that now we can call Francisco from TUMI and our director, Catherine Adler, maybe to give the assignment. Yeah, please. I just would like to say welcome in Luxembourg, because now you should open your branch in Luxembourg. Francisco, welcome.
Thank you very much.
Do you want to take some word?
Yes, of course. Thank you very much for the announcement, for the recognition. As you said, we are from Peru. We have 4 years already of experience with the mining industry, and we are looking forward to bring this experience to the space industry. We are looking forward to be as well a bridge between Europe and Latin America. The last year I had the opportunity to be here 4 times at least, and I was able to see the technologies that could be used already in the mining industry. So there is a lot of opportunities for companies to have real clients and not only finance from government or venture capitalists. And the third is that this is very aligned with the good news we received in Peru during the APEC 2 weeks ago, I believe. We are building in Peru a spaceport in the city of Talara, which is very close to Ecuador. So this is very good news for us, and looking forward to bring more Latin Americans here, bring Europeans to Latin America, and start to do business. Yeah. Thank you very much.
Welcome in Europe, welcome in Luxembourg. So, thank you.
And now we have a coffee break. Thank you so much.
At PwC, we've learned that trust is more important than ever. And big ideas from a community of solvers are what bring change and sustained outcomes that stand the test of time.
At PwC, we understand the power of our people. That it's not just who we are on the job,
but who we are as individuals that makes us special. When our people take on a task, we can tackle the most important challenges facing business and our world.
We're working to build trust in business and society, as we understand the expectations for business to lead in this space.
We know transformation is key to success, and it's what keeps a business thriving and growing. That's why we're helping companies transform for the long term.
We're helping business and society do the right thing on ESG. It's not just a responsibility, but an opportunity to create long-term value.
And we know people are at the heart of it all. The world of work is also changing, so we're helping companies build a productive workforce and overall organization to navigate the journey.
These challenges cannot be solved from a single perspective. They need a human-led, tech-powered community of solvers. These challenges need the new equation.
At PwC, we've learned that trust is more important than ever. And big ideas from a community of solvers